Okay, so maybe we could look at something like this. Looking ahead, when we are here tomorrow, we have what's called, we break this apart in half, okay? The reason we do that is part one would be just like multiple choice questions, and then this is like an A and P vocab quiz, and you have received that content back. So it's just those general questions, and then this type of content is on part one. Part two then would be like your problem evaluation or problem quiz that was handed back. And it's just to give you somewhat of an idea of, okay, this is how well I may or may not understand this content and what we may need to maybe pay attention to moving forward. And as you can see, we do the same thing for the human A and P class as well. We do it for the organic chem class as well. It's because having all this content in one evaluation is just, it's too much content to try to do all at once. And how I like to explain this is, okay, sometimes, okay, if this was the available content inside your brain that it can hold, which it can hold more than this, that's not the point. It's just look at the size, it's a visual aid. But then sometimes if we have this much content that we're trying to place into your minds, if this is full and this is empty, what's going to happen when you start dumping liquid from here that's full into here that's empty? Just by your size evaluation or notice. It's going to do what? It's going to start to overflow. So hopefully when we look at this, it's a way of not trying to do too much all at the same time. And that's why we break it in half like that. So then part two is just problem solving. It's just story problems. I believe maybe 7 or 8 problems, somewhere around that effect, okay? So, what we need to discuss is when you are solving these problems, what type of problem just maybe gives you the most fits? Is it momentums? Is it velocities? Is it accelerations? Is it solving for an initial velocity? Or is it taking content from one portion of a problem and placing it into another part? Maybe that's the most difficult part. I'm asking for input. Oh, that's the Bloodmobile. I believe 16. Yep. My wife doesn't like it when I give blood because she's afraid the next person who receives is going to talk like me. I don't know if that's good or bad. I'll let you decide. Whew. All right. So again, I'm asking for input. These, for those of you having these sidebar conversations, you're just distracting everyone else. And I think that is rude on your part to do that. If you think we're talking about yourself, then we probably are. Notice I'm not looking at anybody. Okay, I'll let you make that determination. So my question is, I'm asking for input. What is it that you would like to work on? Because by tomorrow's too late. It's just like if you are trying to work on something for your all-state course, all-state band audition, something to work on in volleyball, because I know you play Madison tonight. So if there's someone that you really need to avoid because they're one of their best players, if you don't confront that type of conversation and you do at 7:30 tonight, by that time it's possibly too late. My point is that if we address these and we have problems, but we don't address them, by tomorrow it's too late. Can be too late. Or else I'm just going to throw something up there and see once what rolls out of that. Is that what you would like, or would you want specific input? That's all I'm asking.
I have a question with test.
Okay?
I'm confused on how I was supposed to do it on number 2. I don't see how this.
Oh, okay.
Can you like go through that?
Okay. This one right here?
Yep.
Okay. Oh, all right. So we've got this ostrich. Okay? So it's just chugging along, going like this, because that's how they look when they run. Yeah, I don't know. Something like that. Or maybe it's like this. I don't know. Something like that. Okay. So what do we know in this ostrich problem? Or else I can pull up a blank version here so I can make sure we're communicating here. See if I can find one. Otherwise, someone go ahead and read that ostrich problem. We'll fill in the gaps later. Or do I have one here, maybe? Nope. What does it say? Just someone read the problem.
Oh, what is the momentum of an ostrich that is 435 kilograms in size that moves from 2.15 meters per second initially, and then in 3 seconds moves to 5.72 meters per second.
Okay, I didn't catch that last one. After you said something about 3 seconds, then what was it?
5.72 meters per second squared.
Okay. Okay. So I just wrote these numbers down because it's not going to mean anything until you start assigning the variables for this. So it said it was 435 what? Kilograms?
Yep.
So we know that is the label for what variable?
Mass.
That's your mass. Okay? We had 2.15, and that's labeled in meters per second. Okay? But it said something specifically about that 2.15. Did it say initial? Okay. So then velocity initial. Okay? And then this was probably time. It was what, 3 seconds? Okay? And then this 5.72 was labeled how? So when we're labeling it as meters per second squared, what variable is that? That's your acceleration. Now, the question was ultimately asking what was the what of this ostrich. Probably said it in one of the first 2 lines of the question. What was the momentum? What's the variable for momentum? Okay, so as we're looking at that, what 2 variables do we need to know to solve for the variable p/momentum? Let me ask you that first. You need to know mass and velocity. Well, we've got a mass here, and we've got a velocity, but is there something possibly wrong with this velocity? It's an initial, and we need what? We need to have a final, okay? So then with the content that we have here, okay, you correctly said we need that. Once we find the final velocity, then we can find the momentum of this ostrich, okay? So upon doing this, we got to do what the formula tells us to do. Where is one of 2 places where you see final velocity? It's in 2 separate formulas. What would that possibly be? Well, where's the most logical place you could see velocities? In your acceleration formula. Whoever whispered that, we know that we've got this Okay, so there's that variable. Where else could we presume we could find final velocity? It's in another formula. Yeah, okay, so 3 then. Yes, it would be that of the velocity formula, but the problem with that is we don't have a distance here, so we can't solve for velocity. But there's one more that involves this right here. Where do we see mass with a velocity? In which formula? Momentum. Okay, because I was talking the same time that you said that, and when that happens, when the sound of my voice goes this way, it cancels out what you're saying this way. That's why I looked at it. So what did we say? So then here are our 2 formulas, and if you put that on there, you're not wrong. But the problem with this is, okay, so we've circled final velocities, and what's the problem with trying to find the final velocity here? If there's 3 variables, how many of them do you have to know? You have to know 2 of them. Well, we got the mass. We're looking for this. We're also looking for that. So we don't have enough information for that. But do we have enough information here to find that circled value? The answer is yes. So if we do you want me to continue with that? Or okay. So then if we do what this formula tells you to do, which we've got this equal sign, what's on the left-hand side? Which has a value of, okay, so we're doing what this formula tells us to do, 5.82, 5.72. I was just seeing if we're paying attention. Okay. Do you believe that? I wouldn't either. Okay. All right. So then what's on the right-hand side of this equation? We have the initial velocity by plugging those in with what we had set up earlier. We know that 2.15 is here because that's where the formula tells you to put it. What goes in front of the 2.15? Okay? Someone said VF, so that's right. So then what goes on the bottom then? Okay? So how can we get rid of this fraction? What would we do to get rid of this fraction? Someone said 1. You need to be a little more specific when you say the number 1. Right. Because otherwise, if you just say the number 1, I think you're always talking about physical science. That's the number 1. Okay. I'm presuming that means no. Oh, okay. All right, I'll take your word for it too. Labubo would be proud. Did I say that right? No, that was some of you saw this model that I had here. I was putting his organs back inside. Last hour class said, well, we got to give this individual a name because he had male anatomy on him. You can interchange that. They actually can put female anatomy on there. But with this model, I said, so what do we call it? They said Labubo. Labobo? Labubu. Okay? We'll get this right before the end of the day, I hope. Okay. So when we do this, how do we show we're getting rid of our fraction? And for some of us, just out of curiosity, you can probably answer this question. How many times do you think we've shown this process here? 12, 15 times, 20 times? Okay? So our goal is hopefully by doing this, maybe about 20 times that we catch on to that. So if we cross multiply, what is 1 times VF? It's just VF. That's true with anything. A number times a variable or a number times a number. It's just going to give you the same thing. So VF equals That's not showing up very well, so that's why I'm erasing it. So VF, okay, what's 1 times a negative 2.15? Okay, so we cross multiplied here. What else do we need to do? Yeah, multiply those two numbers. And that will get us 3 times 5.72, gives you 17.16. But we still do not have that velocity by itself. We're not going to divide because we're not multiplying here. How do we undo subtraction? Yeah. Yeah, you're going to add 2.15. Okay? So you do that on this side, 2.15. Those are gone, so VF equals whatever happens when you add those two together. So then this, what looks like 19.31. So velocity final is 19.31 meters per second. Now we have this answer, which we can plug into here and say we've got a mass of 435 times 19.31 gives us our momentum. Okay. Yeah, it was a tough question. Typically, you're going to find on any evaluation throughout the course of this semester, what's a problem quiz?
Everything right, but I forgot to, I selected
Yeah.
it instead of that.
Okay, but yeah, which happens. I mean, when it comes to mistakes, there's two things. One, try not to repeat them, and two, try to learn from them. Okay, and that's going to happen. I mean, always. We're always going to make mistakes, but we want to try to learn from them. But what I was going to say is typically whether it's a problem quiz or an exam, there's probably going to be one really tough question on there that, oh my, we really, I think I know what to do here, but if you put them in the wrong order, like maybe what you had done, well then that's where things become incorrect. Anything else you would like to add? Or going back to this input. Or else I'll just throw a couple problems up there quick because sometimes it's hard to visualize these. Okay. So in this scenario, okay, if I'm not mistaken, okay, this, you don't have to draw this unless you feel, I'm not going to tell you have to, but I just put it up here to try to make sense of this, okay? So here we have a hockey rink, okay? So with that, okay, if I'm not mistaken, okay, I mean, I usually just ignore that for the first or second time. Then I won't make things an issue unless it starts to become one. Okay. So what happens is, of course, there's exceptions to in football. You have an untimed down. There's a penalty down on the defense. There's no time on the clock, but yet there's an untimed down that the offense can still play. Okay, in basketball, sometimes you have to go back to, let's say, to a review. If the ball has left the player's hand, the buzzer goes off, and then the ball goes in the hoop. Does that count?
Yes.
Yes. But if the ball is still in their hand when the buzzer goes off, then it doesn't count. My presumption of what we're going to do with hockey here, and I think this is accurate, is if there is a hockey player here, that's just what this X is. Maybe there's a breakaway, and then there's a distance to this goal of maybe, I don't know, I'm going to say 45 meters. I don't know. okay? Because hockey rinks are a little bigger than basketball courts, okay? So what has to happen is, let's say there's only 0.70 seconds left upon review. This player takes a slap shot at this goal, okay? So this puck, okay, that's being shot into this goal, because it's an empty goal. Sometimes they pull the goalie away. And then what happens then, this puck has to be in that goal before time runs out, okay? It has 0.68 seconds to get there, or you could say 0.69 or 0.70, because if the buzzer goes off on replay, if that puck is not in that goal, that it doesn't count. That's what sets that apart from football and basketball. Okay, so now we've got a distance and we've got a time, and maybe this is being shot at, we'll go, I don't know, 61 meters per second. I don't know. I just had made that up, okay? So what the review is saying is maybe compare this scenario. A hockey player takes a shot at the goal. The puck is moving at 61 meters per second from 45 meters away, and there was 0.70 seconds left on the clock. You need to solve for time, and did this puck reach the goal in time? So the hint would say you have to solve for time and compare that answer to how much time was left on the clock. So in this scenario, we're not going to look at this and say, well, we've got all three variables, okay? Remember, we're comparing to this one, okay? So in this case, we read the problem. What do we know when this hockey player takes a shot? The puck is moving at how fast? Which we had established. Which one of these here is how fast? 61, okay? So the velocity equals 61 meters per second. What else do we know in this problem? How far away was this? The distance was, distance of 45, okay? And then what we don't know is the time. And I understand we're saying that there was 0.7 seconds left, but we need to see if that puck is going to reach that goal in 0.7 seconds, okay? I said that's what separates this sport from others. So going all the way back to our first formula that we learned, we've got to do what the formula tells you to do. What goes on the left-hand side? The velocity does, which is 61. What goes on the right-hand side? Okay, now, so it's the distance over time, so 45 goes on top. And then what do we have down here? Our unknown time, because remember, we're comparing to that value. Okay, so just like last time, what is it that we can do to get rid of this fraction? We can cross multiply, which means what is 61 times t? In other words, here's what we're doing. What's 61 times t? If you take a number times a variable, you get that number and the variable. So 61t then equals, we cross multiplied here. What are we going to do here? Same thing. Okay? So then how do we get t all by itself? Because what function are we doing between our number and our variable? What process are we doing with these two? You're multiplying. How do we undo multiplication? Right. So we got to get this all by itself. So we're going to divide this side by what? 61. Okay. And we got to do the same thing over here. So these have now canceled. our time then equals, well, whatever, 45, 0.73? So 0.73 seconds is how long that puck took to get from this spot to here. What does that tell you about the goal? Is it yes? No. No good. It took too long. You only had 0.7 seconds. It took 0.73 seconds to make it that far. That was a good problem. Sometimes it doesn't come out that clear, cut, and dry. Okay? And then maybe there's something. Now, this is what you'd probably see on Wednesday. Because remember, tomorrow is just general questions about what we talked about in lecture and class, and your vocabulary. Okay? Is there anything else? Are conservation of momentum problems, are they causing you fits? In other words, you have two situations where you even say that we got two hockey players, call it a letter A and letter B. If they're moving towards each other, in other words, it's opposite directions, okay? Well, how can we say towards each other if it's opposite directions? Well, it would be the same thing as saying, well, that way's east, this way's west. Those are opposite directions, even though they're coming towards each other. So if this one is moving at maybe 10 meters per second and has a mass of, I'm thinking 85 kilograms. This one's moving in this direction, maybe only at 8 meters per second, but then has a mass of 90 kilograms. Okay? So how would we solve a conservation of momentum upon this collision? They're coming towards each other, they collide. You're going to multiply the two, but then there's one added step. You have to subtract the smaller value from the larger. So then in this case, we've got 850 here, okay? And then this one's 720, okay? So then we subtract these two. So 30 kilograms per meter per second. So which way is it moving? Is it moving towards A or is it moving towards B? Which one's bigger? A's bigger, isn't it? So it's going to move in that direction. So towards B. Okay? Conservation of momentum. You have a larger momentum and a smaller. You just got to subtract the two. And describe, okay, what direction is it moving? Anything else you'd like to add? Okay, sometimes a good one is in softball and baseball. What does it possibly mean if there is a fly ball to the outfield? There's a runner on third. The outfielder catches it, and there are 0 or 1 out. 0 or 1 out. What can that runner on third do? They can tag up, try to go home and score. Okay, so with a distance and a velocity, sometimes we're solving for time for that in baseball or softball. Okay? Yes? Yes, ma'am. Okay? Otherwise, I want you to have time to look at the content so you can organize your thoughts. If there's nothing else, one of the things that we had said the very first day, okay, or if you came to open house, who showed up here for open house? Nobody? Okay. So what would free points possibly be? Does it cost anything to get free points? No, because it's free. So one of the things that you can do, and this is a choice, you don't have to do this. They're called bonus points or bonus questions. Okay? And All you do, it has to look just like we write it, and it has to be turned in tomorrow. Yes. Yes. So, like for instance, if the question would be, okay, this isn't your question, but who was the starting quarterback for Atlanta last night? It was whatever, Penix Jr., whatever. Okay? You can't just write the answer. It has to say who was the starting quarterback for Atlanta last night. It was blank. Does that make sense? You can't just turn in the answer, because this is part of being responsible. Questions on that? Okay. And typically, they're not science related. Sometimes they are, but usually they're not. I'm going to hit pause for just a moment. So here are your bonus questions. We do not do extra credit throughout the course of the semester because we put points in where it counts the most, and that's why this is a choice. You either choose to do this or don't choose to do it, but it has to be turned in tomorrow. So when does this have to be turned in? Tomorrow. So we understand that. So when Wednesday rolls around, we say, oh, I forgot to do my bonus. Can I turn that in? What did you just repeat back to me? It's due tomorrow. Now, if you are not here because you are ill or sick, well then, yes, you can turn that in because you weren't here. Now, if you are also sick or ill tomorrow, the next time that you are in here, you are responsible for part 1 and part 2. Okay? It's if you are gone the day of the review when we're going over this, well then you get that extra day. So the next time that you're in here, you are responsible for taking that evaluation, even if you are gone. Does that make sense? Okay. So what does the X mean? Now, if you forget this, if you forget to have a parent or guardian signature, okay, Mr. Deitch, I don't know, what does this mean? Mr. Deitch will sign this. Mrs. Fritz, what does this mean? Mrs. Fritz can sign this. Okay? That's only 1 point. A parent signature is 2. Now, you don't have to have this signed to turn in. You can just do the questions and get 4 points, and that's it. Even if it's not signed, it's not mandatory to do that. Okay? Make sense? All right. That's all I have. We'll catch up to you next time.